Well, dear friend, here in this video, I will explain you application of elastic behavior of materials. I told you in last previous videos why do we study elasticity. By knowing the elasticity of material, we can estimate the strength of the material, means how much weight can be attached to a rope or a cable without breaking, how much load can be given to a beam, how can we make the bridge which can bear the load of the moving traffic, force of air and the weight of bridge itself. So this all help us, and we can calculate using little higher mathematics differential integration. So first of all, I take here case of crane. You know what are cranes? Cranes are the machines which are used to lift load with the help of cables or ropes from one place to another. Suppose you want to make crane of 10 ton capacity. 10 ton capacity means maximum capacity or weight which it can lift and move from one place to another is 10 tons. 10 tons means 10 into 1000 kg weight is equal to 10 to the power 4 into 10 Newton. 10 Newton. In 10 to the power 5. But for safety purpose, we prepare a rope which can have 10 times the weight. For safety purpose. For safety purpose, we prepare a rope or cable which can bear 10 times the weight lifting capacity. We know the breaking stress of steel is 3 10 to the power 8 10 to the power 8 Pascal or Newton per meter square. Stress, force upon area. So force upon area is equal to stress. So area is equal to force upon stress. The force which it has to bear is 10 to the power 6, 10 to the power 5 to 10 times upon stress 3 10 to the power 8. And it comes out to be area. This area is equal to area of portion rope. अगर ये rope की लंबाई है ये area, this area. It is 1/3 into 10 to the power minus 2 meter square. How many centimeters? Pi r square. 1/3 into 10 to the power minus 2 into 10 to the power 4 centimeter square. यानी कि 100/3 pi r square. और r square equal to 100/3 into 3.14. It is nearly equal to this radius. R is radius equal to 10/3 centimeter, nearly 3 centimeter. A rope of 3 centimeter. A rope of, the radius of the rope come out to be, radius of rope come out to be 3 centimeter. And a rope of radius 3 centimeter will be a bar of steel, 3 centimeters this much, or 6, so it will be a bar, behave like a bar. So we cannot have a rope of this. So steel ropes for this purpose are made of many thin wires which are braided. So to make this rope of radius 3 centimeter is difficult to handle. It will be like bar of steel rod. So the steel ropes are made up of many thin steel wires which are braided together. Braided is to wind up, to wound around each other together like pigtails. Like this, ये ऐसे लिख करते हैं ऐसे. So that is easy to handle, to use it and to make it strong. So that way we have estimated what the diameter of the or radius of the. Now beams are used in making building. The main concern here, bending of beam under its own weight and the weight suspended by it. Suppose here it is a beam of length L, depth D, length L. When suspend weight, it may bend like this. It may bend like this. So the depression here, this much, will be the delta depression. But center here or now here. So this bending of beam should not take place. So what to do? It has been calculated using calculus that delta is equal to, this delta is equal to, let the weight suspended be W. WL cube upon 4BD cube into Y. The depression or the bending by delta. W is the weight suspended, L is the length, B the breadth, and D the depth, and Y the young modulus. So higher the young modulus, lesser will the depression. Here, smaller the length, greater the lesser the deviation. But we have a limit. Our room should be of 10 meter length and breadth. So when we make the roof of this, the lintel से करते हैं, तो how much beam should be there? Here depth is more effective than breadth because delta proportional to B power minus 1 D minus 3. So therefore we make the beams of large depth. You might have seen the beam in the roof of the big rooms which are coming out of the roof. But in small rooms this is not required because load is very small. So, but now if we use beams of large depth, then like this, suppose it was beam depth, ये beam depth होगी, so it can buckle under its own weight like this. It may buckle like this. अभी पहले ये था under its own weight, it get buckles. For this to avoid this buckling, what we can do? We can use this I shape. Here it is. So by making the ends of larger area, reduce the weight of the beam itself. It reduces the and stop buckling. That is why the rail of train, the rails on which train run are of I shape. The top is wider and the bottom is wider, and in between the top and base, the iron that is thin like this. So we use elastic behavior like this. Now we make building pillars. A pillar of round shape also get bent or can bear less weight. So to increase the weight, we take the shape like this. The ends are made wider. Actually, the load applies pressure. Pressure is equal to force upon area. By increasing this area, we can decrease pressure. So this helps us in making the pillars which can be used to bear the weight of top of building and bridges also. Now we come height of mountains. Heights of mountain not more than 10 kilometers. Why? Actually the shape of mountains are like this somewhere, and so the at bottom the stones are not having equal weight, so this uneven distribution produce shear stress. By knowing shear stress I told you model of rigidity is the ability of material to maintain shape and size. So under shear stress, the stone below this start flowing, like if there is a dump of dust or sand and we push by leg, then there is no turn back. If the weight of the material of the mountain has stress more than breaking stress of stone, then the stone will flow. So if breaking stress of stone, breaking stress of stones is nearly 3 into 10 to the power 6. I mean 3 into 10 to the power 8 Newton per meter square. Density of rocks is nearly 3 into 10 to the power 3 kg per meter cube. Breaking stress, force upon area, and force divided by area is equal to pressure. Force upon area equal to stress. कितना 3 into 10 to the power 8 न्यूटन. और ब्रेकिंग स्ट्रेस तो कितना फोर्स इज इक्वल टू HDG by it is pressure, force upon area, equal to 3 into 10 to the power 8. तो H into 10 3 into 10 to the power 3 और G10 ले लिया हमने 3 into 10 to the power 8. So 3 cancel. So x equal to 10 to the power 8 upon 10 to the power 4 in 10 to the power 4 meter, यानी कि 10 kilometer, which is more than the height of Everest. So no mountain has height more than 10 kilometers. If you don't get it clear, you can read NCERT book and other book to read it again. Actually, I am giving the simply idea. Sometimes something may be missing from here. So this is breaking stress. So please read these things. General people ask question, why do we start study elasticity of material? Now in coming videos, I will take numericals from this chapter, which will be very important for you for every exam, whether it is competitive or your class exam, class 11 exam. That is, and dear student, class 11 is very important class because it is the base of learning science. If bases are, the fundamental are missing, then it becomes difficult to understand. Like if you don't know tables, you can't multiply and divide. So keep on learning hard.